As long as you practice these two things, I think you should be pretty safe. Personally, I've never used any crypto bridge in my entire life. And this is why we're building Hyperbridge, because I will finally have a bridge that I can use. I mean, if I wanted to bridge to optimism, there's just no way I'm going to wait 7 days to get out. And so then I have to use, some alternative system, and then, wait 10 minutes anxiously to see if I get my money out on the other side. It's just not for me. I prefer to have peace of mind.
Thank you for tuning into the TEACHMEDEFI podcast for another episode. Today, this episode will be about interoperability between blockchains, why we want blockchains to be able to communicate with each other and share data, the challenge of making this communication secure. Within this framework, we'll also chat more specifically about bridging or crypto bridges, which many people might be familiar with. A quick primer on the topic: transferring assets across different blockchains faces significant challenges, especially with bridge protocols facilitating these transfers. I believe between 2020 and 2022, we had over $2.5 billion that were stolen due to bridge vulnerabilities. A notable example is the Ronin bridge used by Axie Infinity, which lost over 600 million to hackers. And beyond security issues, bridges often have limitations like supporting only a few tokens, being difficult or slow to use, requiring extra steps for transactions, which makes using them harder as well. So, plus transferring coins is still a rather basic level of all the ways that blockchains could communicate with each other. So for broader adoption of crypto and DeFi, enhancing security, user experience, and interoperability features appears to be essential. I'm excited that today I have the pleasure of talking to Seun, co-founder of a blockchain research and development lab called Polytope Labs. They've recently introduced Hyperbridge, a unique cross-chain bridge protocol to address many of the issues associated with bridging today. Hi, Seun. Thank you for coming onto the show.
Hey, it's really great to be here, actually. A big fan of your work as well.
Thank you so much. I'm glad. Lovely to link up, and I think it's such an interesting topic that can be discussed in much technical detail, but it's also a bit accessible because of all the stories around bridging and all that. But before we get into that, can you tell us a bit about your journey to this day in the crypto industry? What has that been like for you?
Yeah, for sure. So I kind of got crypto pilled back in 2017 by my coworker at the time. He was telling me to buy Bitcoin. And I remember like, okay, why should I buy Bitcoin was my question. He's like, well, it goes up. And that was really all he said. That was really all he said. And I was like, that just sounds to me like a Ponzi. And, I'm not really interested in Ponzis. But I remember he had bought a lot of Bitcoin, and I think Bitcoin hit like 1,000 or something. I don't remember, way back in the day. Yeah. And he just couldn't shut up about it. And I just, decided to look into what Bitcoin was. And, that's kind of how I fell down the rabbit hole of this idea of, decentralization, internet native money, and like freeing ourselves from the shackles of like central banks and basically, separation of money and state. So I was really I really went the crypto anarchist path rather than just buying tokens for the Ponzi of it. And so once I, understood Bitcoin enough, and I was working as a software engineer at the time, the next logical step was Ethereum, right? So Ethereum was also sort of coming up at the time. It was kind of like second most talked about protocol. So I looked into it a bit, and I found out, you could actually go further and not just have money, but have programmable decentralized applications on the blockchain, which is another mind-blowing moment for me. So I just became obsessed with Ethereum, and I started, reading the protocol, sort of trying to see how I could contribute to the ecosystem. I was doing a lot of open source Rust tooling for the Ethereum ecosystem at the time. This was around 2017, 2018. And I remember I was browsing through the subreddit, the Ethereum subreddit, because, as I'm obsessed at this point, and I see a job post for a Parity, right? So the Parity team, they say they're looking for people to come and work on an Ethereum client in Rust.
All right.
And, that was like really, really, like, it was incredible that people were actually putting Rust in production, because this was around the same time, 2017. Rust was not even version 1 yet. It was like very, very hobbyist, very, very, it wasn't that like polished, but it was a promising language. And I was just excited to write Rust and excited to work on Ethereum. So I applied, and I got hired in 2018. Sort of September 2018, and I remember I had my last call with Gav, and it was very, very surreal, like meeting the person who actually wrote the Ethereum yellow paper, and just trying to get his thoughts on kind of where the industry's headed. So that was exciting. I was at Parity for 3 years. I left in 2021 in August, and this was after working on the Rust Ethereum client, the substrate blockchain framework, as well as Polkadot itself. So after working at the core infrastructure, I just wanted to know, okay, what are the sort of applications for all of this infrastructure that we've built, right? I had a focus on interoperability, and this is a very philosophical standpoint for me, because if we see networks kind of as states these days, and I think that the network state paradigm and movement is starting to take the industry by storm, is that if we see these different networks as states and they don't have any trade routes, bridges between each other, then we kind of basically created the same problem we started with, which was that we had all these different countries and there was no interoperable money between these countries, right? Except for people who actually come together, like the EU, to actually create their own interoperable money. And so it's very clear that the success of this industry will hinge on the success of the bridges that connect all these different networks together, which is why I really loved working on Polkadot. And so I was looking to build more interoperable infrastructure. So I joined Composable, and I think this is what made me very popular in the Polkadot space. We were working on IBC implementation on Polkadot, and this would allow us to bridge directly to Cosmos rather. And IBC is a really, really I would say way ahead of its time, using light clients and using state proofs to bridge securely across multiple blockchains, but it had its own limitations. And so after putting this project in production, because it's live today, I wanted to see how we could build a much better system without the limitations of IBC and be able to bring, secure interoperability to all the blockchains and not just on a chain to chain basis, right? So that's kind of been the story so far. I don't know if there's anything that's worth covering more.
Yeah, I mean, super interesting. I hear the theme of interoperability sort of like weaving its way throughout your journey there. I think it would be interesting to hear from you, what does interoperability mean? Because I think it would be interesting to hear this defined by someone working on it, because it can often be like a bit of a superficial buzzword to people, and people have their own beliefs attached to it. They think maybe they understand the concept, but maybe it's a bit more of a superficial understanding or false understanding. And perhaps why is it important? You kind of mentioned it already, but for example, is the end goal the bridging of just assets between blockchains, or does it go beyond that, the way blockchains could communicate with each other? What excites you there?
Right. So from a high level, interoperability just means being able to share data with, between blockchains. Now, it's the case that this data might be instructions for what this blockchain should do, e.g. mint some new tokens because I've burnt them on one side, or maybe it's to an application letting you know of something that's happened on this blockchain, right? So sort of like a reaction or a hook. I guess that's what they call it these days. From my perspective, I think that token bridging will first, of course, be the most successful application of bridges. But as time goes on, more and more, applications will start to emerge. I think the most important, or the second most important thing, would be cross-chain governance. And to give you more context on this is that we now start to have DAOs that have their applications deployed across multiple chains. It's the case that these applications actually are governed by the DAO. Their parameters, basically the parameters and the way they function are governed by the DAOs. It's clear that if the DAO is going to be effective at governing multiple applications across different chains, then it does need to broadcast, right, the governance action to all of its applications securely, by the way, because if a malicious person was able to compromise that flow of governance action, then all of these applications are basically compromised, right? So it needs to do this securely. And so I think cross-chain governance is going to be one of the biggest applications of cross-chain bridging. And there's other ideas like cross-chain privacy as well. Privacy has sort of been reduced to basically being in a private set, kind of like Tornado Cash, where you add yourself to the set. It's the case that on a single blockchain, the set isn't very large, and it basically makes it easy for anyone who's very savvy to detect who's going in and who's going out and draw links between them, especially if there's not a lot of people or a lot of traffic in the set. But you can imagine if we have a multi-chain set, so it's a set that actually spans across multiple chains, this starts to become very, very hard for anyone to detect who's going in and who's coming out. And especially if it's the case, you can just go into the set on one chain and just come out on the other chain. So this is another application of cross-chain bridging and interoperability that I think will also be very successful. And honestly, the list goes on, right? Like I could sit here all day and tell you all the potential applications of interoperability.
Yeah, it's super interesting. Cross-chain governance and cross-chain privacy. If we look at the current most implemented use case, like you said, the token bridging, for anyone asking themselves this, either looking in from the outside or having been personally affected by it, why do we see so many hacks in crypto and specifically of bridges? Is this industry doomed, or is there more to this?
So as a person who's been working on blockchains for the past 6 years, thereabouts now, it's the case that a lot of people who build these bridges don't have any experience building blockchains themselves. Typically, you find that they're smart contract developers. And so their perspective is, how do I just authorize at the smart contract level messages that are flowing between two chains? And, very often they just come to the conclusion we should have a multi-sig, right, that sits in the middle and does this authorization, because you do need authorization. You need something to authorize that this message came from the counterparty blockchain. But this is, of course, not secure, because if you can compromise this person in the middle, this entity in the middle, then you can basically authorize the withdrawal of all of the funds that are locked on the bridge. And this is, like you said, what we've seen so far. I think the most recent one was the multi-chain attack, where the control of the funds was usually with the team, right? So the team is the people who control the bridged funds, and the Chinese government just came in and says, well, give us all the money. And it's the case that they can do this, right? Because they control the keys, they control the funds. And so a more superior architecture for bridging would be to use the finality proofs of the chain that you're bridging as the authorization. So these are cryptographic proofs that cannot be created by anybody except for the validators of the counterparty chain. And I'll give you an example. As a user, you want to use the blockchain. You want to know what's happening on the blockchain as well, right? In a sense, you want to be bridged, to the blockchain. You want to see what's happening securely.
Nice one.
Exactly, right? So you run a full node of the network that you're intending to read and write to. And this full node, what it's doing is that it's downloading all of the blocks from the network. It's checking all of these finality proofs, right? It's checking all of this, state transition proofs, basically checking that the blocks themselves are valid. And that's basically it. And so if we want that same level of security in bridges, then at the very least, we should also be checking finality proofs on the blockchain, which means that, only the counterparty chain can be used to authorize messages that are coming from it. Now, this is very expensive, actually, and this is why no one tries to do this, is because these proofs are very expensive to verify on-chain, and then you start to need, very complicated ZK and all these, protocol designs to make this possible in the first place. But if you're a person that's been working on blockchains for the longest of times, then you can start to see optimizations that you can take that don't necessarily need all these expensive ZK proofs to make it possible in the first place. And that's kind of how Hyperbridge sort of works at a high level as well. But I think that if we want to see more secure bridges, then this sort of consensus-based bridging has to proliferate, basically, and has to take over all of this multi-sig and MPC solutions that are currently holding the industry hostage, in my opinion. Because if you look at the DeFi Llama dashboard, every single bridge on there uses some sort of multi-sig or the other. If you ask anyone, they'll tell you that this is basically a time bomb, a ticking time bomb. But who are we to judge?
Wow. I was going to dive into that later, but now that you mentioned the sort of prevalent use of these bridges with multi-sigs and custodied funds and all that, why are we using these bridges? Is it what is it that drives that? Is it ease of use or integration? Is it even influence of backers of these projects, or liquidity, or how cheap they are for the end user, or does the end user also not understand the risk, and then the low costs, ease of use, and branding outweigh the perceived risk? Like, what is it?
I think it's a healthy combination of everything you just described.
Yeah.
First off, these kinds of bridges, they're very, very cheap to run because they're not doing all this expensive verification in the first place. Secondly, the backers, especially if you have very notable backers in the industry, it's very easy to get people to use your bridge because they just trust that, okay, whoever backed you is a high signal enough for us to trust you with our funds. But at the same time, it's not the case that the users themselves are the ones that get compromised whenever these bridges are compromised. It's actually the LPs, right? So the LPs are the people who supply the liquidity on both sides of the bridges to facilitate people who want the native token on the other end. So these are the people that often get the short end of the stick whenever these bridges get compromised. And so at the same time, though, it's like there's also no other alternatives, right? There's no light client-based alternative that's on the market right now for both LPs and both for users. And so this is also lack of alternatives to drive people to use whatever, right? And it's the case that like bridges are very, very critical. So like I said, this entire space. Imagine if I wanted to move from one chain to the other, I'd have to send my money to Binance and, swap it on Binance so that I could withdraw to the, it's still the same thing. It's still the same thing. And so we need a more decentralized alternative if we want this space to actually prosper in terms of liquidity flows and seamless liquidity flows for users. But we'll see how the industry plays out. Hyperbridge is definitely going to be one of the players in the space who adhere very closely to the security philosophies of don't trust, verify, and enabling more secure bridges in the space.
Tell me more about that. What does that decentralized solution look like? What are you guys working on there?
Right. So I take a step back first and describe sort of conventionally how bridges will be built, especially in a light client paradigm. So in this light client paradigm, you have this piece of code that runs on one blockchain, and it's receiving, the headers, the blocks, in a sense of the blockchain it's bridged to, and it's verifying all these cryptography proofs of the validity of these chains. And then you do the same thing on the other side. You mirror this. Now you've bridged two blockchains. And if you wanted to bridge a third blockchain, these two blockchains now have to have extra code and do extra work to verify this third blockchain. And this third blockchain too would have to do, two more different processes to verify. And you can start to see that as we add more chains to the mix, it starts to become very cumbersome to do all of this verification on chain. It's super expensive. So this is the point-to-point model. And you can see this also, it does parallels with bridges in the blockchain space with also airline route planning, right? So you can have this point-to-point model where you just fly direct, and it's super expensive, especially if you don't have a lot of passengers. And there's downtimes in people that are flying, so you're just incurring all these unnecessary losses. And you can sort of parallel that with the sort of scaling and verification costs in this also point-to-point bridging model. And so there's another idea. What if you have a hub and a spoke model where rather than every chain running all these different light clients for all these different chains. They run a single light client for the hub. Now, the hub itself, all it does is it runs the light clients of all of its connected chains. So it's aggregating all of the verified states of all these different blockchains. And so with a single proof to any blockchain, they can receive what is the verified states of all the chains that the hub is connected to. So you can now start to see how this scales. This is now a one-to-N bridge, whereas before we had a one-to-one bridge, which grows from end to end as well. And so this is a much more superior architecture. It's much more scalable. It's cheap to run, and it's cheap to verify. But the thing is, though, is that you need high economic security for the hub. Like the hub itself has to have a large amount of value that is staked to back its consensus, just so that it doesn't become a security vulnerability for all of its connected chains.
Like a single point of failure or anything like that. Essentially.
And so it's the case that Polkadot itself has this high economic security. Like right now, it's the case that its total amount of assets that are staked are worth over $5 billion. Now, this is sufficient enough for it to be a hub, not just for the parachains, but also for external chains as well. So Hyperbridge is extending Polkadot's interoperability and its shared security, not just to parachains alone, but to external chains, and allowing them to sort of benefit from the economic security that it provides. So fundamentally, Hyperbridge runs off of economic security.
Right. Okay. Super interesting. By the way, I saw your post on the airlines, on the airline industry. By the way, I really like your posts on X. I like them, but I rarely understand them.
Yeah, no, I get that a lot as well. I'm basically schizo posting, mix of shit posting and schizo posting. I try to take very sarcastic posts about different ideas, and as well as just examining very closely ideas that I think will become prevalent in the future as well. And one of those posts was that analogy you just used with the point to point and the hub and spoke model. So could you tell us a bit more about that? How that would look like using Polkadot and Polkadot's economic security then as this hub and spoke model, where you connect sort of all these different airports or blockchains. Just to get an idea. But would the assets flow, for example, if it's token bridging, would it flow through Polkadot then, or what does it look like? So let's say in a token bridging model, and maybe to touch a bit more on token bridging, is that the reason we have token bridging the way it is today, with LPs and people supplying liquidity on both sides of the bridge, is because these bridges themselves, they know that they have very terrible security. In an ideal world, you wouldn't need liquidity on both sides. You would be able to burn the tokens and authorize them to be minted on the other side.
Because you're not generating a new amount of tokens. It's just they're gone there, they appear here, so to say. Yeah,
exactly. This is way more capital efficient. Obviously, it prevents unnecessary liquidity to being locked up so that it can be used more in lending and dexes and places that actually do need liquidity, not bridges. And Circle, they realized this, right? Because there's just so much USDC locked up across all these different bridges. It doesn't make any sense. Let's unify them all. And they introduced the CCIP or the CCTP, where they will mint and burn USDC across these different chains, rather than having liquidity be locked up for swapping wrapped assets with the native USDC. So this is just much more capital efficient. It's much more seamless for users and for everyone in general. But it's the case that because you don't have these secure bridges, they have to now do all of this pools and do all of this swapping for getting the native assets. But if you have a very, very secure bridge, then you could basically do this mint and burn. IBC, the IBC protocol in the Cosmos ecosystem, they do mint and burn. They don't need to do all of this liquidity, provisioning and swapping with the native asset, because they just burn the asset on one end and they print it on the other end. The same thing happens in parachain world, right? Like you burn the token, the dots on the relay chain, you get it minted on whatever parachain you're bridging, so and it's instant, right? And it's secured by the relay chain. And so, if we want to bring this capital efficient bridging to other chains, then we need to get rid of all these pools and use the finality proofs of the chain to authorize the minting. And the finality proofs also shows that it has been burnt on the counterparty chain. So as a result, this is, like I said, this is just much more seamless for users, and it's less of a, it takes up less capital in general.
Right.
So that's just one application, just one of the ways in which we can, this new idea will change bridging. But go ahead.
No, yeah, just expanding on that. So you mentioned Circle and USDC. So they're obviously just doing that with their tokens, so to say. Could Hyperbridge do this then for all kinds of tokens? Could it even do it, for example, in that case, for USDC, this authorization thing in terms of minting and burning? And
Yeah, I think that it's the case that we will work with DAOs and in general, people who have these multiple applications across different chains, or just in general DAOs who want to take their token multi-chain without incurring all the liquidity costs to do so with all these conventional bridges. So you can think of us as a more decentralized alternative to Circle's CCTP. I think that the CCTP is a bad idea because it's still the same problem, right? You have this centralized middleman who is able to mint and burn and can also be compromised. People will say, well, it's the same security as Circle themselves because they already mint arbitrary tokens in anywhere. But, I would assume that this minting previously was controlled by some sort of cold wallet system, right? But now it's the case that, you have a hot wallet that's trying to facilitate this bridging, which is really a security risk. So long term, I think Circle should want to switch to a decentralized alternative that uses the necessary proofs to transport tokens.
Right. And in terms of implementing this for a token, like the integration of a token for the Hyperbridge, do you have to, like, for example, contact the DAO behind the token to get like this approval or something in order to be able to do that? Or can you just like permissionlessly do these things?
Right. So no, we do need the DAO approval. And I think DAOs are also starting to look out for bridge partners as well. Like Uniswap, Lido, all these different DAOs who, they'll have a token and they want this token to be native across all these different chains. The integration process is pretty simple, it's very seamless. They basically extend their token contracts with some adapters that our bridge needs, which you can then use to mint and burn this token across all these different chains.
Okay. And this is how is this then more secure in terms of that they don't have to trust, that they don't have the vulnerability of a single point of failure? I assume it has to do with these light clients. Is there a way to explain this in a sort of like a not very techie fashion so I and someone else can understand?
Yeah, for sure. So, we have what are called these validators of the chain. And sure, their job is to produce blocks, but their job is also to vote on which sequence of blocks are finalized, right? Everyone's familiar with this word finalized. But how does this actually work? Well, the voting is done through these cryptographic signatures. So it's just, data that they produce using their keys that says, well, this chain has not been finalized. And if you have enough signatures from what we call these super majorities, so 2/3 of the validators, then this is proof that that this chain has been finalized. So a light client really is a piece of code that is able to verify these signatures from the validators and is able to track the chain as they produce more proofs. So also tracking when the validators themselves change, right? Because they vote on what is the next set going to be. So that's at a high level what a light client is. And you can now start to see that a light client basically inherits the security of the blockchain itself. If it's the case that a light client were to be compromised, then the blockchain itself is compromised, right? Because you now have this Byzantine set and they're producing proofs for conflicting chains, which would cost them a lot in the amount that they've staked. So this is why we come back to the argument that we do need high economic security for light clients to use.
So basically, for these applications or the DAOs behind these tokens, it would be in their interest to integrate a solution like Hyperbridge, because there's less trust assumptions and it's more secure and essentially better for their own ecosystem.
Basically, yes.
Yeah. Okay. What's your favorite part of what you do, actually? I mean, it can be high stress. You're trying to secure these bridges of money of people going across it, So what do you love about it?
I mean, I love the math, the cryptography part of it. I think that it's insane that we're able to do what we do because of all of these cryptographic primitives. It's I'm a nerd, basically. And the possibility of these things, they just blow my mind. They actually just blow my mind. And just being able to work with them in my day job, something that I'm excited about, is really unmatched.
Yeah, that's worth a lot. Yeah. What do you do to kind of get away from it, decompress, relax?
So I play tennis, lawn tennis, on Sundays. So it's, one of the ways I use to return to baseline, and that's kind of a pun because in tennis you have the baseline. And I play video games as well. I hang out with my friends, and I read books as well. So that kind of the varying activities that I do. I also go to the gym once in a while.
Well, that's funny. I play tennis. Yeah, nice. I play tennis as well.
Nice. We should play.
Yeah, definitely. You're just a bit too far away right now, but
don't worry, we'll make it happen.
Yeah, nice. You mentioned like long tennis, or did you just mean like the normal one? Like, is there another thing, or?
Oh, I just, to disambiguate from table tennis, because usually I mention tennis and people think I'm table tennis, but I do play table tennis, but I prefer lawn tennis because it's just more intense, especially on your knees.
Yeah. What's your favorite, what's the English word for it? The ground, like the courts? Is it on clay or on hard courts?
I prefer the hard courts. I've tried clay. I've played grass as well. It's clay is very tricky because you can fall if you're not careful. And the grass courts, they don't bounce very much. I think hard courts are just like the best sweet spot.
Yeah. Me as well. I'm left-handed, so you can put a bit of a slice on a hard court and it does do more than on clay. So
for sure. The left-handed people, you got to watch out for them.
Yeah. I know no one likes to play against them.
I guess it's dangerous.
If we back to the whole bridging and interoperability space, what do you actually think about the state of the Ethereum layer 2 landscape at the moment? Is this becoming the go-to place for thriving, performant, interconnected applications, or is it becoming increasingly messy and fragmented? Could it even hurt the ecosystem entirely? What's your take on this?
Yeah, for sure. Actually, I was having a conversation with someone else on Twitter about this, and I think that Ethereum itself already has all of these network effects, already has all of this liquidity. It's natural that it will become a roll-up hub. It's impossible, though, for it to become a bridge hub. And I've written extensively about this on our blog, but I'll just recap some of the facts. So there are really two kinds of rollups. You have the optimistic rollup and you have the ZK rollups. The optimistic rollups, they have the advantage that they can do more computation because they're not kind of bounded by the main L1. They can produce a lot of blocks. The only thing they need to do is to post the data of these blocks on Ethereum. And now there's this new idea that in fact they should just post it somewhere else entirely. And I'll get into all of that later, but they just post it somewhere else entirely, and then they just post the commitments, about what is the latest state of the chain to Ethereum. Basically, at that point, they're no longer, in my opinion, a roll-up. They're more like an L1 that just doesn't have its own consensus in a weird way. But the problem with these rollups, and we'll tackle optimistic rollups first, is that they have this very high finality period, right? Which makes bridging in between them basically impossible. Yeah. This is where all of these sort of multi-sig bridges, they thrive because they can provide faster finality, even though it's just backed by a multi-sig across these different rollups. This, to me, presents systemic risk. Because users are not going to use the canonical bridges because it's just too slow. 7 days, who's going to wait for that? And so it puts the entire ecosystem on these multi-sig bridges that have all these risks that I've described earlier. And so it becomes very, very problematic as we now start to launch more and more rollups, and it's not clear how we're going to bridge these rollups together and provide higher security bridging for our users, right? People just seem to discount the fact that people are going to want to bridge in and out of your rollup. They just only look at it as a one-way, tokens are now on my rollup, and ideally they would never leave, right? Which is just not the case. And so there are now ideas around, okay, maybe shared sequencing. It's not really clear what benefits this provides. And there's ideas around pre-confirmation as well, which is a bit risky because pre-confirmation leverages cryptoeconomic security to sort of provide sort of a stake that says, I'm backing this roll-up block as valid, even though we've not checked it. Which means that you're no longer inheriting the security of Ethereum. You're now inheriting whatever the security is of whatever chain is providing you this pre-confirmation. So this is where Hyperbridge actually comes in as maybe the only solution to provide secure bridging across optimistic rollups, is because we are able to first off follow the finality of Ethereum. So every rollup block first has to be finalized by Ethereum, and then we can provide this extra service of checking the blocks of the optimistic rollups. So we do so by re-executing them on a parachain or within a parachain block. So this is kind of how Moonbeam works today, right? The Moonbeam is an EVM blockchain, and it sends its blocks to Polkadot to be validated, to be executed. And in the same way, we can just package up all these roll-up blocks, put them inside of a parachain block, and send them up to Polkadot to be executed so that we can get validity guarantees. And then we can bridge back the results of this execution to be used for bridging to other roll-ups on Ethereum. And this sort of hub and spoke model, like we described earlier. And so this is kind of how I see really the roll-up landscape and bridges play now, is that we will need external services that, on top of Ethereum security, can also provide validity checks. In fact, some people are already trying to see if you can do this with ZK. So the Risk Zero team, they came out with this protocol or product called Zeth. And it's basically, they took the Reth code base, which is in Rust, and they were able to put it into their Risk 5 ZKVM, and you're able to then produce proofs that this block is valid. But the problem with this is that it's super expensive. You have to run like 64 machines in parallel, a lot of communication complexity there as well. And it takes an hour for all of these machines to produce a single proof. Now, you have to understand that these optimistic rollups are producing a block every 2 seconds. So, any kind of ZK solution to bridge them is just not going to work. And this is where Polkadot really, really shines, is because Polkadot has this bandwidth for compute, right? We can start to run a single rollup on multiple parachains. In fact, we can split up the blocks across these different parachains and just execute them in parallel. And, parachains now have 6-second block times. And in fact, I think they're trying to make that even to 2-second block times. And just by executing these blocks across these different parachains, we can assert the validity of whether these rollup blocks are valid. And this is comparable to if we just did it in a ZK circuit, right? So until we have solutions like this, rollups are really going to just stay fragmented and will be held hostage by all of these different multi-sig protocols for bridging. Now, there's also ideas around intent-centric bridging, but you can't really bridge arbitrary data. You can't use this to do cross-chain governance. It's only for tokens. You lock up some tokens on one end, and someone else will give you the tokens on the other end. That's kind of how these intent bridges work, like a cross and hop. But like I said, you can't use them to bridge arbitrary data just for tokens alone. So yeah, that's kind of my take on sort of the global L2 landscape. And of course, we're going to keep getting more and more L2s. I think optimistic rollups are cheaper than ZK rollups, cheaper to run.
Yeah.
And yeah, they also have just way more profit as well. We can see these numbers in the L2 fees website. So you can see the profit margins for the optimistic rollups versus the ZK rollups. Sure, you have to understand that the ZK rollups, on top of on-chain verification costs, they're also paying massive prover costs in the background that they don't report. So it's unlikely that they're even profitable in the first place, to be honest.
Okay.
So this is where we're focused mostly on optimistic rollups. Even at the same time, ZK rollups themselves, they don't post the proofs immediately. They post them typically after a day. So it's like 4 to 24 hours after the block is posted to L1. So in a sense, they're still mostly optimistic, right?
Yeah.
So this is kind of the landscape, and this is kind of how I see a solution that bridges all of them working, basically being able to confirm block validity on top of Ethereum's finality.
Right. Yeah, this sounds also like there's a solid basis in terms of economic feasibility for your solution, and just being a cheaper and then a secure solution, and opposed to the other ones, which is always good in order to establish a market position, so to say. Right. And how would it look on Polkadot in terms of, you mentioned parachains? Would Hyperbridge then have its own parachain, or would existing parachains could they opt in to do these proofs? Or how would it go?
Not necessarily. We will definitely have our own parachain, but not just one parachain. In fact, we're looking to have multiple parachain slots on Polkadot. And all these parachains, they're all natively interoperable. We can read the results of one parachain on a single parachain. So you can imagine you have all of these worker parachains, and then we have a single master parachain. And when these worker cores are done, we just read the result of their execution on one chain, and we're able to do whatever processing that we need to do to bridge them back out.
Right. And how does establishing Hyperbridge and Polkadot as this hub drive value to the network of Polkadot as well?
So, because it's the case that we're purchasing core time, we're going to be leasing slots, all of the computation that we do on the network for bridging is basically going back to the network, right? Like it's not going to be us that sort of reap the benefits. It's mostly going to be the network. But of course, at the same time, block space and core time is very cheap right now. I think most of all the parachain blocks are pretty empty. So I think this is also a really, really great time for us to be building this sort of infrastructure and taking advantage of all of this compute that Polkadot has is basically unused.
Right. Yeah, that's true. That's everything's coming together the way I'm hearing, and also, so the lack or the limitations and the gap that exists on Ethereum's L2 landscape could be something that drives network usage substantially on Polkadot, or?
Fundamentally, yes. This is how this would eventually play out, I think.
Right. What about these models like Thorchain? They say there's native cross-chain swaps that can be done through them. I know there was a bit of controversy around it recently with, I think, like illicit activity going through there, and there could have been some measures to limit that. Like, for example, to say, okay, one transaction, you could essentially say one transaction can't be larger than X $million or something, which like probably 98% of users don't need to do in one transaction anyway. But yeah, anyways, how does that model fit in this whole thing in terms of like cross-chain bridging?
Right. So Thorchain is just another multi-sig system, this is kind of I would say an alternative to having a multi-sig, like a blatant multi-sig like Layer 0, is that you say you have a chain, and this chain has its validators who are a multi-sig, and they're signing on what to do on all these different chains. Thorchain itself has been exploited in the past, I think twice now. And it's just a problem, like I said, with all these multi-sig security solutions, is that they are essentially a middleman, right, in between the blockchain that introduces security risk. So Thorchain itself, they just have pools on all these different chains, and they're able to use the chain that's in the middle to sign on what to do on all the different chains. But at the end of the day, whether it's a chain, whether it's a community of people who are signing, it's still a multi-sig, which is just not as secure as relaying the consensus proofs and using that as authorization rather than a middleman.
Right. Okay. There's also been some recent events that I wanted to hear your views about. I saw this post about Bitcoin by Nikita Zavaronkov. I hope I said that right. The average Bitcoin transaction fee is now $50 with 300,000 transactions waiting to be confirmed. This is beyond ridiculous and unusable. Historically, this is the point when people start running away to alternative blockchains en masse. Then there was a post about the blockchain avalanche by Cited, saying, I went from $500 in Avex wallet to $50 because of a couple failed transactions. Nice. And I never even got my transaction through. Right. And then there was the Arbitrum sequencer that went down a few days ago. Arbitrum stopped producing blocks. For the people who don't know, what's a sequencer? It's responsible for ordering and processing transactions before they're finalized on Ethereum. And Arbitrum has one, I believe. It's centralized and went down, so the chain was not usable. So what's going on, Seun? What does this say about the current state of crypto? What are your thoughts?
Right. So I think that first off, there's this new inscriptions craze where people are basically spamming every blockchain with all these useless transactions with data that may not be useful on chain, but maybe is useful off chain. Who knows? And a lot of the chains are now sort of crumbling under the weight of all of these inscriptions because they're driving up the gas prices. Yeah, it's to be expected. We've seen this already play out before with NFT mints on Ethereum mainnet and kind of how that sends the gas prices skyrocketing. I think the Arbitrum case is very, very peculiar because I would assume that the sequencer went down because of a memory issue, it ran out of memory. Because, it's the case that if you have a single machine, then all the transactions on the network in the mempool have to be stored in memory. And if your machine isn't as beefy as it needs to be, then basically it crashes the machine. And also as a single block producing machine, it needs to know all the transactions in the mempool, right? Because it's the single block producer. It needs to be able to order these transactions and put them into a block. In a decentralized network, this wouldn't happen because each machine kind of doesn't need to know the entire mempool. This work is shared across all the different machines. But in the case of Arbitrum, because of this centralized single sequencer, that makes a lot of sense that it went down. Maybe when they decentralized this wouldn't be an issue going forward, but it's the cost of centralization, in my opinion.
As in, the cost of centralization, that something like this could happen. That's what you mean. Yeah. What is next for Polytope Labs? What's coming up? What are the future plans? You kind of mentioned the parachains and perhaps even multiple parachains. Would there be a token? Does there need to be a token? Would the token power this? And what are you building on right now? What's next?
So right now we're working on the final pieces of the puzzle of Hyperbridge. So right now what we have on testnet is more of a POC. We need to swap out some of these parts to make them mainnet ready, boosting the security, making it super cheap. Maybe an example of this is our vertical tree scheme, which makes our state proofs the cheapest possible. So users can enjoy high security, but with very low fees. And then finally, we're switching out our Ethereum Light client for the full beacon chain Light client. So we have a protocol. It's called ZK Casper. It's really the only one in the industry, and it allows us to track the full Ethereum validator set. It's over 880,000 right now. So being able to verify signatures from all of these people means that we're benefiting from the entirety of the staked ETH rather than a subsample of this committee, which most bridges use today. I think Succinct, Electron Labs, and even Near, all of them use this sync committee, which is like just 512 people subsampled from the entire set. In my opinion, it's not very secure, especially when you pair the fact that there's a whole network, the proposer, or I want to say the builder relay network, which allows you to do MEV and allows you to request signatures from really any member of the validator set. You can see how we can use this to request signatures from the members of the sync committee to perform like client attacks. And also you take into the fact that the sync committee cannot be slashed. And even if they could be slashed, the amount at stake is so low that it doesn't even make any sense. So the only way you can have a truly secure bridge to Ethereum is if you're validating the full set. And it's also the case that this is not just possible inside of a snark. It's just too many signatures. But we're able to do this because we do this on a parachain. We dedicate a single parachain to this, and it does all of the verification, and then we're able to read the results of that verification, and then use it for bridging. So this is also something that's only possible on Polkadot, to be honest with you. And so once we have these two pieces in place, then we're ready for mainnet. We're already looking to do partnerships. For instance, Rob Habmar is working on a data availability layer on Polkadot. So basically using Polkadot to store roll-up data for Ethereum roll-ups. They will need to bridge, of course, their data availability proofs to Ethereum using Hyperbridge. So really looking forward to that. As well as just partnering with DAOs for Gateway as well, our token bridging solution, allowing them to bridge their tokens to all these different chains that we support, pre-mainnet, securing these critical partnerships. Sure. So in the question of tokens, well, yes, we will need a token for governance. And the reason for this is, imagine you had a ZK-like client contract on Ethereum or whatever, but this ZK-like client contract, it needs to be upgradable, right? So that you can change the consensus, if the underlying consensus changes on the counterparty chain, you need to be able to update this consensus-like client on Ethereum. But if you now do this with a multi-sig, then you no longer have a ZK-like client. You have a multi-sig bridge, because the multi-sig governs the code and it can be used to swap it out for a malicious contract that doesn't do any verification. And, this compromises the bridge. Yeah. And so in order to avoid this, we do need to have decentralized governance on our chain, which controls our code on our parachains, and basically making this no longer dependent on, whatever the Polytope Labs team is thinking about, but the broader community and their needs. So this is why we will have a token at some point, but it's not really in the plans on mainnet launch, unfortunately. We think the token will come much later after launch.
Okay, some token alpha here. You heard it first. Also, it sounds like you're kind of showcasing a lot of unique capabilities with Hyperbridge that Polkadot has. I mean, the decentralized governance thing is another one.
Yeah, for sure. It's so important, especially, with this new regulatory crackdown on protocols that may be super centralized. By making this decentralized, we're not just, it's not just a meme, but we're kind of absolving ourselves of the responsibility of the network and sort of bringing in the community to also take part in being responsible for the network.
And real quick, because you mentioned data availability, which is also a big topic at the moment with Celestia and all that. And could you just explain what's happening there again? What's data availability? Why are solutions like Celestia being used by L2s? And then mention how Polkadot could actually tie into that and be used as for that, because you did mention this.
Right. So if you go back to the roll-up paradigm where you need to post the block data to Ethereum, it turns out that Ethereum doesn't have the bandwidth to process all of this block data from all these multiple roll-ups. It's super expensive. It drives up the cost of Ethereum's block price on mainnet. So people are starting to realize, okay, maybe we can post the data elsewhere on another decentralized blockchain, and this decentralized blockchain will be bridged to Ethereum so that we can show using state proofs that our block data is in that blockchain. Right? So this way we still maintain the fact that the data is available and it's a decentralized network, and not that it's a centralized network and we're just withholding the data. So, networks like Celestia, they're, taking advantage of this fact that Ethereum itself doesn't scale with data, and they're also providing data availability. It's the case that, Polkadot has already built a lot of all of this data availability protocols way back in 2018, 2019. Every parachain block is kind of erasure coded and made available to all of the relay chain validators, and they can reconstruct it on their own, data availability sampling, and re-execute the blocks if need be. And so, I had started a conversation about this on the fellowship channel. That was last year, December, and I was trying to propose that we could actually open up Polkadot's data availability protocol to people who want to post data, for roll-ups or for, what have you. Doesn't really matter. Yeah. And this could be another way that Polkadot provides a service to different blockchains. And I think recently Rob...
What came out of that?
So Rob recently started working on this problem and basically exposing Polkadot's data availability to different chains. And Polkadot is Polkadot has so much, and I want to say compute, but as well as data throughput, because all of this compute needs data throughput, right? Because you need to be able to process the data for the compute. So it's two sides of the same coin. So the same way we have all these cores that can process code, is the same way they can also process data as well. So you can imagine that because each core is allocated a maximum of 5 megabytes of data for its compute. So you can imagine if you just keep stacking all these cores together, then you can now have very, very high throughput data that allows people to post, their roll-up blocks in those data slots, and they can be secured by the Polkadot relay chain. And this is, like I said, this is what Rob is working on right now, and I think they will have a major announcement soon. Don't want to spoil anything. They recently made their repo open source, and I kind of tweeted about it as an alpha leak, and just kind of went viral. But I think it's super exciting stuff, and I think that Polkadot is going to have the most data throughput of any data availability chain because of this sharded nature of its execution and data requirements of this execution.
Oh, wow. Okay, I'm glad I asked that question. That was also super interesting to hear that there is actual things coming up on that front.
Yeah, it's exciting. I think it's Polkadot is slowly transitioning from trying to serve just parachains and serve L1s, but also serve other protocols through high economic security, high compute and data throughputs. Yeah.
Which makes a lot of sense in terms of the interoperability narrative and the mission that Polkadot is after. Right. Perhaps pivoting to a bit of a different question. You and your co-founder, David, you're Nigerian, and I was curious about your views on Africa and the crypto space because my insight is limited there. How do you see the role of Nigeria and Africa in like the global blockchain ecosystem, perhaps both on the developer and the user side? Like what trends are you seeing? What are challenges and opportunities there? And perhaps like could the blockchain space benefit from embracing Africa as a market and a talent pool more? And if so, how? That was a lot of questions, but just curious on your opinion on this.
Yeah, so first off, Nigeria has the largest developer community in Africa, and this is from a recent GitHub survey about like what are the developer trends, and I think Nigeria ranked the largest growing developer community in the world, based on the year-over-year changes. So it's a huge untapped market in terms of developers for sure. But at the same time, sub-Saharan Africa in general, now not just Nigeria, but sub-Saharan Africa is growing as one of the largest users of stablecoins. And I think there were some reports, and I might have to bring this up later on because I don't have it with me, but shows that there's been over $800 billion of stablecoin settlements generated by sub-Saharan Africa alone in the past year. Wow. So not only do we have the largest number of developers, but we also have the largest number of users in the space. And, there's lots of reasons for this. High inflation, lack of financial inclusion, the list goes on. So in my opinion, this is one of the things that drives our work here at Polytope Labs is that if we're already the largest users of crypto in the world, then how come we don't build all of this, critical crypto infrastructure, right? We go back to the Web2 space, right, where basically Web2 was mostly built by Silicon Valley, right? Mostly built by the West, and the reason for this was because they had more advanced computers, they had more advanced networking, and they got all of these things before the rest of the world.
Right.
But right now, the only thing that you need to build all of this different Web3 infrastructure is just a bit knowledge of cryptography, so a little bit of math. And that's about it, right? And crypto is a much more decentralized system. It's different people from different countries that are pushing the industry forward. It's not just one set of people, right? So this presents an opportunity for us to also shape the industry in a way that caters to our own needs as well, because it's very different that people build products for you and these people are outside the country versus someone who's in the country who understands the needs, understands the users, understands the ecosystem, and can then take all of these and then build a product that caters to all of these different things. And we're already seeing this happen, actually. We're seeing, for instance, look at Tron and how it's been able to be very successful in China. Same thing with BNB. Look at Polygon and how it's been able to be very successful in India. I think that crypto is going to be local first, not necessarily the same way we've seen before with the Web2 space, where we just have one region that just broadcasts software and its services out into the world. It's more that we will see local first adoption. So this is, like I said, this is what drives us and drives our mission at Polytope Labs. And we're also trying to grow the community as well. We tend to host all these different developers. We do ZK meetups, we do protocol meetups. We used to also do substrate developer boot camps back in the day, training people in the substrate framework. Unfortunately, there's not a lot of opportunities in the substrate framework right now, so we're kind of scaling that back. But there's opportunities in ZK, and so we're also bringing that up as well. I think that if we're able to grow the community, grow the developer community, they will drive user adoption. And there's already like it's already a fertile ground, in my opinion, because of all the different factors, economic and financial inclusivity factors that will just eat up all the applications and all of the sort of projects that may spawn from a cohesive community of developers.
Right. Why do you think that is? That firstly, super interesting to hear that, I'm glad you shared all that. Why do you think it is that now it is more easy to have? It's less in terms of you have like one hub that's in San Francisco or whatever, but now you can actually build up more locally these communities. Is it because of the decentralized fashion of this technology, where like you can get involved and let's say put out a protocol or code on these decentralized networks without having to have this like physical infrastructure, hardware, which is already highly developed? Is this contributing to it?
Yeah, so I think it's mostly because of how the industry is still in its early research days, right? I think of this whole blockchain space as a research experiment, but of course it has its applications, right? And so because of it's still in its early days, and it really builds on infrastructure that's already publicly available, like cloud compute, blockchain nodes. This is really widely accessible to anyone. The only part of it that actually kind of needs development is the code, the protocols. And this is also very accessible to anyone. So this, I think, contributes to the decentralized nature of its development, because anyone with a laptop, anyone with, developer experience, they can just pick it up and start to hack on new ideas and new protocols, and they can, deploy this onto a decentralized network, and instantly everybody in the world has access to it. I think that's very, very powerful. I think that's not something that the Web2 space had. And I think that just because of the fact of this is that we will start to see more and more people from very obscure places all over the world contributing to the global landscape. And I think that's exciting, more representation in terms of technology and technology development.
Yeah, for sure. More and more like the barriers are becoming in terms of like knowledge and access to education only-ish, and less in terms of like where you are or like other barriers that you might have.
Exactly.
I think.
Yeah.
But oh yeah, and we'll put all those we'll put links to the things you mentioned in the show notes in terms of if people want to get involved with your meetups or anything like that, and get involved with Polytope Labs more, they can.
Yeah, for sure. I'll send everything over.
Sweet. Finally, to wrap it up, perhaps, is there any actionable, practical advice that we can leave viewers with regarding bridges? Are there any heuristics they can use, a mental model, any simple steps they can go by in their head to make sure they protect themselves as good as they can?
Safe bridging. Well, it's the case that, like I said, there's not a lot of safe bridges at the moment. But I would say, as a rule of thumb, do not LP into bridges that have a very shady security model. I think even the Polkadot people also got burned by the recent multi-chain bridge hack. And so you want to avoid, first off, getting wrapped assets. If the bridge is going to give you wrapped assets, just avoid the bridge in general. If it gives you a native asset, then it doesn't really matter how it does that, because you're kind of insulated from when it fails. It's the LPs who will be burnt when it fails. But at the same time, also don't LP to bridges that have this multi-sig security model. But yeah, as long as you practice these two things, I think you should be pretty safe. Personally, I've never used any crypto bridge in my entire life. And this is why we're building Hyperbridge, because I'll finally have a bridge that I can use. Yes, so for sure. Because, if I wanted to bridge to optimism, there's just no way I'm going to wait 7 days to get out. And so then I have to use, some alternative system, and then, wait 10 minutes anxiously to see if I get my money out on the other side. It's just not for me. I prefer to have peace of mind, whatever it is I'm doing. And, the same peace of mind you have when you use Ethereum is the same peace of mind you should have when you use a bridge. And I don't think any of the bridges out there provide that. So this is why we're building it.
Yeah, you're really putting your money where your mouth is, so to say, Basically, it's always good to see a co-founder do that for a project. Well, thank you so much, Seun. That was very insightful. One of my faves for sure. Thank you for coming on the show. All the best to you guys. We will be on the lookout for any announcements that you were already kind of give us hints about. And you're always welcome on the show. And thank you for coming on.
Thank you for having me, sir. It's always great to be here.